Alright, we're going to continue with Chapter 12, Section 2. And our warm-up is a problem like yesterday. It says the inverse variation x times y equals 8 is the speed in miles per hour times the time in hours. So speed times time equals distance. And that would be in miles, because a mile per hour times an hour is a mile. Alright, so we're going to graph this and use that to estimate how many hours to go 4.5 miles per hour. So if you have x times y equals 8, that's the same exact thing as y equals 8 over x. So if we made a table, then 1 mile per hour would take 8 hours. 2 miles per hour would take 4 hours. 3 is going to be some sort of decimal. 4 miles per hour would take 2 hours. 5 is a decimal, 6 is a decimal, 7 is a decimal, 8 is 1 hour. Now, the question is 4.5. It's asking us to use the graph. But if we put 4.5 in for our equation for x, this answer is just 8 divided by 4.5. So if you do that on a calculator, you get 1.7 repeating. So 1 and 0.777 of an hour. A graph of this and the negatives wouldn't make sense because negative time, negative miles per hour and negative time don't really exist. So we're not even going to look at this quadrant of it. We're just going to look at the positives. So this is your miles per hour, this is your hours, and this is your distance of 8 miles. So remember, 0 is an asymptote. It's never going to touch this, and it's never going to touch this axis. It's a divide by x. This is our equation that we're graphing. So 1 is going to give us 8. 2 is 4. I'm going to jump over to 4, which is 2. I'm going to jump down to 8, which is 1. So we have this hyperbolic curve, like so, never touching either axis. So 4.5 would be right here, and that gives us the 1.7777. Alright, today we're going to talk about rational functions, and that is any equation that has a letter in the denominator. So this one has a letter in the denominator, this one has a letter in the denominator, this one has a letter in the denominator. Now, if you have a letter in the denominator, we know that in the calculator, if you put 2 divided by 0, you would get error. So the denominator cannot equal 0. So there's excluded values. So for this equation, the domain is restricted. So x, can never equal 0. And that's why there's the asymptote. And I'm getting that because I'm thinking, when will x be 0? And that's at 0. So that's our exclusion. So over here, my exclusion would be when x minus 2 equals 0, because that cannot happen. So my exclusion is that x cannot equal 2. I would add 2 to both sides. If I plugged a 2 in for this, I would get 6 divided by 0, which is error. So what this is telling me is initially right here, x can never equal 0. That's this asymptote. And this one, x can never equal 2. This is the new asymptote. So this bottom part, this minus 2, means we have shifted this graph to the right too. So our excluded value would be x cannot equal 2, which is what this question is asking. All right, now we're going to compare 1 over x minus 3, and 1 over x minus 3 plus 2. I'm going to pull these up on the calculator. I know that this minus 3 from what we just looked at is going to shift it to the right 3. And then if we just add 2 to every single answer, that should shift it up 2. So my graphing calculator, I have typed in, let's see, the first equation, 1 over x. The second equation I made like a bold line, 1 over x minus 3. And the third equation I made a dotted line, which is 1 over x minus 3, and then we're adding 2. You'd have to put x minus 3 in parentheses so that the whole x minus was all divided. All right, so if I hit graph, the first equation is 1 over x. The second one graphing right now is 1 over x minus 3. And the last one that graphed is 1 over x minus 3 and then added 2. So that last one is the one that is 2 higher. So this one right here was shifted right 3. And this one right here was shifted right 3 and up 2. Whoops. And that was the last one. And the base one, the parent function, the initial one, has the asymptotes at both the x and y axis. And this is explaining that an asymptote is something that it'll never cross. They'll get closer and closer to it, never touching it. Asymptotes are usually drawn with dotted lines like this. So this asymptote is the x equals 0 line, and this asymptote is the y equals 0 line. So essentially it cannot equal 0. All right, so if you look at this equation, our new asymptote is at x cannot equal 3, and our new horizontal asymptote is at this number. So y will never equal 2. And y will never equal 2 because this part will never equal 0. So you could never get 2. So initially, there's nothing added, so x cannot equal 0 is my vertical asymptote. This is my vertical. And then my horizontal, there's nothing that's added or subtracted here. So my horizontal is also at y equals 0. So we're looking at the shifting to the right or the left, which changes the vertical asymptote, as well as shifting up or down, which changes the horizontal asymptote. So for 2 over x, the vertical asymptote is at 0. And the horizontal asymptote, I could put this plus 0, if it makes sense. That's how you get your horizontal asymptote. In this next one right here, my vertical asymptote is right here. X cannot equal -2. If it did, the denominator would equal 0. My horizontal asymptote is this number right here. Y will never equal 4 because this part will never equal 0. So that is my horizontal at 4, my vertical at -2. So we're going to identify these asymptotes. So my vertical is x will never equal negative 7. If it did, the denominator would be 0. My horizontal is that y will never equal 0. There's nothing added here, so since this part will never equal 0, y will never equal 0. In the second one here, my vertical asymptote is that 2x minus 3 will never equal 0. To solve this, I'm going to add 3 and then divide by 2. So my vertical asymptote is that x will never equal 3/2, or x will never equal 1.5. My horizontal asymptote is this number. This will never equal 0, therefore y will never equal 8. So once I know this, it's a really good base to figure out what numbers I should start plugging in. If I know that at 8, this is going on, and if I know that at 1.5, this is going on, if I have a positive, which I do, my graph is going to be somewhere up here and somewhere down here. So to plug the numbers in, I'm going to plug a few numbers in on the x value on the right of 1.5. I'm going to plug a few numbers in on the x value on the left of 1.5. And that's how I'm going to generate my entire graph. So my vertical asymptote is that x is not going to equal 3. If it did, that would be 0. And my horizontal asymptote, y is never going to equal 0. There's nothing added, so that's how I'm getting 0. Therefore, I know my graph is going to lie somewhere in this quadrant and somewhere in this quadrant, you know, looking like this. Let me get rid of those two. So I'm going to plug in a couple numbers up here to the right of 3, because it's not going to equal 3. So maybe I'll plug in 4 and 5. So if I plug in 4 for x, I'm plugging it right in here for x. 4 minus 3 is 1, and 2 over 1 is 2. If I plug in 5, 5 minus 3 is 2, and 2 over 2 is 1. So 4 is going to give me 2, and 5 is going to give me 1. So my hyperbola up here looks like this. If you want to plug in 6, you'd get 6 minus 3, which is 3, so 6 would be 2/3. Now, 3 is an asymptote. So now I need to plug in numbers before 3. So maybe 2, 1, and 0. So 2 over 2 minus 3 is 2 over negative 1, which is negative 2. 2 over 1 minus 3 is 2 over negative 2, which is negative 1. 2 over 0 minus 3 is 2 over negative 3, which is negative 2/3. So 0 is negative 2/3. 1 is negative 1. 2 is negative 2. This is a hyperbolic curve. This is not linear. It's never going to touch either asymptote, so the graph that you're looking at is the blue and the black lines. All right, if we look at the next one here, my vertical asymptote is x cannot equal negative 4. So at negative 4, I'm going to make my asymptote line. My horizontal is that y cannot equal negative 2. I know y will never equal negative 2 because this part is never going to equal 0. So at negative 2, I have a horizontal asymptote. So to plug numbers in here, I'm going to plug in a few numbers above -4 and a few numbers below -4. So remember, -4 is my asymptote. So we could plug in like -5, -6, -7. And we could also plug in -3, -2, -1. So if I plug in -5, 1 over -5 plus 4 is 1 over -1. That's -1. And -1 minus 2 is -3. If I plug in -6, 1 over -6 plus 4 is 1 over -2. So that's -1/2. -1/2 minus 2 is -2.5. If I plug in 7, negative 1 over -7 plus 4 is -1/3. -1/3 minus 2 is -2.1/3. So -5 is going to give me -3. -6 is 2.5. -7 is 2.1/3. So that makes sense because our hyperbolic curve should look like this, being very close to the asymptotes but never touching. Now if you plug in -3, 1 over -3 plus 4 is 1 over 1, which is 1, and 1 minus 2 is -1. 1 over -2 plus 4 is 1/2. 1/2 minus 2 is -1.5. 1 over -1 plus 4 is 1/3. 1/3 minus 2 is 1 2/3 negative. So, -3 is -1. -2 is -1.5. -1 is -1 2/3, -1.6. So this one is going to be right here. So that's the graph of that rational function. All right, one more. A librarian has a budget of $500 to buy copies. She's going to get 10 free copies, and we're going to figure out the number of copies of the program that she can buy, where X is the price per copy. Okay, so our vertical asymptote is X cannot equal 0. I'm getting that because the denominator can't equal 0. Our horizontal asymptote is Y cannot equal 10 because this part will never equal 0, so Y will never equal 10. I'm going to, I guess, go down a little bit farther. I'll rewrite this right here. So Y will never equal 10. And X will never equal 0. Now, most likely, the positive hyperbola is going to be here and here. The negatives don't really make sense. It wouldn't make sense to get negative copies, so I'm not going to worry about the negative numbers. I'm just going to focus on this curve up here in this area. So the numbers I'm going to plug in are going to be X values that are more than 0, and my answers should be numbers that are more than 10. So if I plug in something more than 0, if I plug in 1, I would have 500 over 1, which is 500, and 500 plus 10 is 510. If I plug in 2, 500 divided by 2 is 250. 250 plus 10 is 260. If I plug in 3, I'm going to get a crazy decimal. So let's plug in 4. So 500 divided by 4 is 125, plus 10 is 135. If I plug in 5, I get 100, plus 10 is 110. If I plug in 10, I get 50, plus 10, which is 60. If I plug in 50, I get 10 plus 10, which is 20. If I plug in 25 right in the middle there, I would get 20 plus 10, which is 30. Alright, so numbering by 1 is probably not such a good idea. So I'm going to renumber this axis. I'm going to count by, let's see, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. I'll count by tens. So again, the Y is the number of copies and the X is the price per copy. Alright, so we'll make this counting by 2's. Let's go 2's. So we're going to end up over here at 40. So we're not really going to end up with this on our graph. We're also not really going to end up with these two numbers on our graph because they're going to be off of our graph. But we can plot the middle numbers. So 4 is 135. 5 is 110. 10 is 60, and 25, which is right here, is 30. So if we went way over here to 50, which is going to be somewhere over here, we're going to be at 20. So our hyperbola, if I could hit my dots here, oh boy, just make our dots bigger, is swooping down. It's going to get very close to 10. Remember, it's never going to cross 10. This is our other asymptote. And it's going to get very close to 0, never crossing 0. But it is literally shooting way up because 1 and 2 are neither on this grid. So the reasonable domain, the domain are all of the numbers greater than 0, and the range is all of numbers greater than 10. So the domain, the numbers for x, such that x is greater than 0, and the range, the numbers for y, such that y is greater than 10. So just a quick recap. So far this year, we've done y equals mx plus b. Those are linear equations. We've done the quadratics, which are ax squared plus bx plus c. We looked at them more in factored form. We're going to get to this whole line of symmetry thing, so don't worry about this just yet. You're going to be experts momentarily. We've not looked at square root functions a ton yet, since I'm doing chapter 12 out of order. We're going to get there though. And now we're looking at this, where this is the shift. If it's a minus, it shifts it to the right. So this would shift it right B, and this would shift it up C. And the basic parent function of a hyperbola of this inverse relationship is right here with asymptotes at the zeros. The asymptotes do shift when you add to the denominator and when you add to the whole equation. And again, we will do the square root function later. I'll put coming soon. for your enjoyment. Okay, well, I hope that made perfect sense, and I will see you all tomorrow.